let's dive into Kotlin's functional aspects. In this section, you'll learn about extension functions and extension values. These are incredibly handy constructs that allow you to, at least by appearance, add new functions, values, and variables to existing classes. Higher order functions are functions that accept other functions as parameters. If you pair these two together, we can create builders which allow you to create hierarchy of objects with a very nice syntax and API. Operator overloading allows you to change what a certain operator means in a certain setting. Hand in hand with that goes infix functions, which, if used correctly, can reduce noise and increase readability of your APIs. Welcome to extending existing classes with extension functions. In this video, we'll learn about extension functions. We'll discuss some use cases to give you an idea of how to use them in your own applications. We'll look at how extension functions are actually implemented, as well as the syntax for defining them. Extension functions allow you to add new functions to existing classes, even though you don't have write access to those classes, and you don't even need to recompile those classes. If you know how the JVM operates, you might be shouting witchcraft about now and saying that's not possible. And you would in fact be correct. So under the covers, they are in fact implemented as static helper methods. But at the call site, it looks like you're calling a function on the target class directly. You can actually call these extension functions from Java, but then you'll have to use the static helper method pattern. I'm guessing you're pretty tired of the person class by now, so let's do something completely different. Let's create a JavaFX application. Don't worry if you don't know JavaFX from before. I'm going to introduce you to the concepts you need to understand this example. We'll start by defining an application entry point. So we'll call this my app, and it needs to extend the JavaFX application class. Next, we're going to implement the start function. So I hit Ctrl-I, and I select the start function. You may notice that IntelliJ suggests that the primary stage passed to this function can be null. And the reason for this is that since we're extending a Java API, Kotlin can't really know if the primary stage can ever be null. I know though that it can't, so I'm going to remove this nullable statement. The primary stage is like the window, the top level window of a JavaFX application. Inside of the stage you need to place a scene, and inside of the scene you need to place a root node. We're going to use a VBox as our root node. A VBox is a vertical layout container. So we'll start by defining this VBox and call it root. Now we're going to operate on the primary stage, and we're going to do several things with it. So instead of repeating primary stage dot this and primary stage dot that, we could use apply. But there is an alternative which looks even better in this case, and that is with. So with primary stage, let's do something. So it works like apply. So inside of the code block, this would be the stage. One of the differences, apart from the syntax, is that you can actually return something from with. You can't from apply. It would just return the object that you're applying on. So if I were to create a string here, for example, then I could pick it up by assigning to it here. So you can see now that x would be a string. If I change this last thing inside of the block to an int, then x would be an int. We're not really interested in that aspect of with, just the syntax of it, so we'll leave it like this. Now we need to assign to the scene of the primary stage. So we say scene is, and then we create a new scene object. And our root is going to be the VBox. And next we want to show the primary stage, so we call show. Imagine the alternative here. It would be primary stage scene equals scene root, and then primary stage dot show. So it's a lot more repetitive, and you kind of just left with more of the essence of your code instead of just boilerplate where you repeat the variable names all the time. So that's why I like this syntax. So what we have now is an empty scene with a VBox in it. So let's add a label inside of the VBox. Most of the layout containers in JavaFX have a children list, and that's where you can add other nodes. So in the children list of the VBox, we're going to add a new label. And in this label, we're going to put a string, call it Hello Kotlin. This is all we need for our first initial application, but we need to run it. So let's create a main method here. And we're going to call a JavaFX function called application.launch. So application.launch. Then we need to pass it the class name, the myapp.class. So to get to the Java class, we actually have to go through the K class that we would get if we write myapp::class. So this returns a K class object. Don't worry about this for now, we're going to revisit this in the next part. From a K class object, I can get a normal Java class by calling .java. That's what we need to do to be able to tell the JavaFX runtime that our application entry point is myapp. So let's run this. Our application is working, but it's not very elegant. So let's see what extension functions can help us with regards to improving this API. Of course, we can't change the JavaFX API. That's pretty set. But what we can do is extend it with functions that would help us to create our UI. Let's shut this down. And let's look at this. So we have this VBox where we access the children list, and then we add, and then we create a new label, and we set the text of this label. Wouldn't it be nice to be able to say root.label and then hello Kotlin? That would be pretty nice. So how can we do that? Let's define an extension function that is operating on the VBox. So we could say fun VBox.label. Now we know that this label is going to take a text parameter. So let's call this text of type string. And what we want to do here is to access the children list. Whenever you create an extension function like this, this here is going to be an instance of the class that you define the function on. So that means that I can actually access children directly. So children add, and then a new label, and then the text. That's all I need to do to be able to remove this and replace it with this much more concise version of exactly the same code. Now, of course, a VBox is not the only place you would like to be able to use this label function. What if we changed this to an HBox instead? So HBox, as you probably guessed, is horizontal layout container. So it's going to lay out its children horizontally instead of vertically. Since we only have a single children, we're not even going to see any difference here. But we'd like this function to work on both VBox and HBox, and you may have guessed the answer is not this. That's not the way to go. So let's investigate HBox and look at what it extends. Oh, so it extends pane. Let's hit Ctrl-Alt-B and see what else extends pane. It looks like pane is a superclass for a lot of containers and actually other stuff as well in TornadoFX. So looks like pane would be a better target for our extension function. So let's go back and change this function from VBox to pane. We need to import it, of course. And now the label function is available on all layout containers. Let's add another node to our HBox. This time it's going to be a button. So this would be the way to do it without extension functions. So we would create a button and set the label for the button. Let's set it to click me. Now we can access the setOnAction function to determine what's going to happen when we click the button. Next we need again to access the children list, call add, and give it the button. So we could run it just to see how it works, and then we will improve upon this. Alright, so the extension function could again work on pane. So a function pane.button. Again, it could take a text parameter, and you could do the same. Children add, then a button, and then the text. The thing is that we need that button back so that we can call setOnAction for it. So we need to make sure that we return a button here. So this time we're going to need the function body. So we can add that, and then we could return that button. So either we could create this local variable and then return it here, or we could use apply when we create it. So this is one explicit alternative. The other would be to create the button here, set the text, then call apply. Now we're already returning the button, so what we need to do here is actually to access the children list of the pane, not the button. So to do that, we can say this, and you can see we have two alternatives. This would be the button. This @button would be the pane. The reason for this is that I'm now referencing the function and the function's object. So this @button is going to refer to the pane instead of the button. So now I can access children and then add this, since we're operating on the button inside of apply. So this allows us to clean this up so we no longer need this one. And we can say here root.button instead. You can also see a repetitive pattern here now. So every time I create a node, I'm adding it to the children list of the parent, if you will. So we could reduce some more boilerplate by creating a pane.add function, which takes a node. And let's see, we import node. And this function should return the original pane, I guess. So we can return this and then call children add node. Now we don't need to reference children before we can call the add function. So once again, it removes a little boilerplate. Let's rerun the application to see that it still works as it did before. Since button is now actually returning a button, we don't really need to assign to a button value anymore. We can simply chain these together, so we can say button and then set on action. By now the API looks pretty good, but you can see that we're actually repeating the word root a lot. So it might be nice to use apply on the hbox and move these functions inside of the apply and remove the call to root. So now we're starting to see a builder pattern emerge where we try to avoid repeating the values, and we're kind of building a hierarchy of nodes here. The builders we created are slightly different, so let's look at the differences between them. The first one here, we don't specify a return type, so let's ask IntelliJ to help us define the return type. So right now it's pane. And why is it pane? Well, we operate on pane and then we call add. And add returns a pane. So that's why it returns a pane right now. It might make more sense for it to return a label just like the button. So if this was supposed to be a production-ready API, we would probably do what we did with the button function and return the button itself. In the pane.add function, we define that we want to return a pane just like we do with button. But instead of using apply, we do the more explicit return this. So the end result is the same, but it's two different styles.